Alright, yo, good morning. My name is Rodolfo Rodriguez, and I'll be showing you guys a video on a toy transformer truck that turned into a toy gun. And I'll be describing three gas principles and chemical principles that are involved with it, and I will also be showing you guys how to solve a Boyle's law equation. So yeah, let me start off by making my screen smaller so you guys can see the video I'm about to show you guys. Yeah. Alright, alright. So this is what the gun's gonna look like at first, or the toy, and yeah, it's basically a normal truck. But the way you transform into a gun is you open up these slides right here, and you put your hand in the back, and you pull out this lever that will make it transform into a gun. And as you guys can see right here, this orange thing, when he pulls that back, as you guys can see right here, yeah, when he pulls that back, that causes the volume to decrease and the pressure to increase. And that's going to be important to know for this next slide. So the first chemical principle that I'll be describing is Boyle's law. And right here, this shows what it's like when he pulls this thing back. So when he pulls that back, that's this picture, the second picture right here. So when he pulls it back, these particles are like colliding into walls, and they're trying to push back at a certain force. So when he lets go of it, when he like increases the pressure, when he pulls the trigger, these particles, like, they push back in a strong force, and that's what causes the bullet to like go out the gun like strong. So yeah, that's one. And this next slide is going to be the formula for pressure, which is force over area. So this is the formula for pressure, and this is basically saying the smaller the area, the bigger the force. So as you guys can see right here, this area is small, so the force is going to be huge. So that's why the bullet travels at like the strong force. So that's two. And one last one is going to be plastic, high density and low density. So alright, this is a good picture. So what this first line means is that the density is low. It's like easy to break. It's like weak. And this right here, as you guys can see, there's like many branches. What this means is that the density is high and it's not that easy to break. So for example, right here, I have a water bottle. This is like a good representation of low density. As you guys can see, it's like weak. It's easy to break. It's easy to like squish. So yeah, that would be like low density. And high density would be like this pill bottle. This pill bottle has like, I don't know, it's strong. You can't squeeze it as easy. You can't break it. It's pretty strong, and that's like high density. And how that correlates to the gun is that it's made out of high density plastic, so it's not that easy to break. Yeah, that's three chemical principles that are involved with this gun, this toy, and I'll now be showing you guys how to solve a oh shit. I'll just be showing you guys how to solve a Boyle's law equation. So yeah. Let's see. I can make this bigger. Alright, so alright. Alright, I need the camera to focus, hold on. There you go, okay, fun. Alright, so this is a Boyle's law problem. So I'll read it out for you guys. A 2.0 liter container of nitrogen had a pressure of 3.2 atm. What volume would be necessary to decrease the pressure to 1.0 atm? Question mark. So what I like doing first is circling the given. The first given is V1, which is 2.0 liters. The second given is P1, which is 3.2 atm. And the last given is P2, which is 1.0 atm. And we're looking for the volume, right? Well, volume, we're looking for V2. And I wrote out the givens right here. So so yeah, the formula for Boyle's law is P1 times V1 equals P2 times V2. So yeah, as you guys can see, I wrote it down right here. P1 is 3.2 atm times 2.0 liters, which is V1, and equals 1.0 atm times question mark. So yeah, what 3.2? So you multiply 3.2 times 2.0, which is 6.4. Equals 1.0 times question mark. Since we don't know what that is, I divided 1.0 to both sides, and that equals 6.4. So the answer for V2 would be 6.4. So let me write that, hold on. So V2 equals 6.4 liters. So that would be the volume necessary to decrease the pressure to 1.0 atm. And that's basically the end of the video. So yeah, thanks for watching. I hope I get an A. And yeah, peace.